This week we're going to take a look at a couple exercises from chapter 24, and the two exercises we're going to look at are going to actually be those first two, exercise 24-1 and exercise 24-2. The first exercise is going to be a payback period computation. So we're going to see our company is considering the purchase of an asset for $180,000, so that would be our cash outflows. And we've got an expectation for cash inflows that are listed here. And you can also note that those are not going to be even cash flows. So some years we might have 60,000, the next year we might have 40,000. So we want to compute the payback period for this investment, and what that's going to be is in what year, or how many years rather, would it take to recoup the 180,000 cash outflow. The way we're going to set this up is have our 5 years listed vertically on the left-hand side. And then we're going to put our cash inflow or outflow. And then here we have the initial year zero cash outflow of 180,000, so we'll put it in parentheses. And then we're also going to look at our cumulative net cash. So this is going to be either an inflow or an outflow, and we'll mark outflows again with parentheses. So right now we have no cash inflows, so we have 180,000 is going to also be the cumulative. And we are going to see in the payback period calculation when that cumulative net cash flow would reach zero. So year one, we have a cash inflow of 60,000, which would make the cumulative 120,000 outflow. Year two has a 40,000, so we have 80,000 for the cumulative as an outflow. Year three, we have 70,000 for a cash inflow, so 10,000 for a net cash outflow. So after 3 years, we still have not recouped the full 180,000. Year four, we have 125,000 for the cash inflow. So you'll see a little bit after the 3rd year is when we are going to have the payback period computation. We're going to have a net cash inflow at the end of year four for 115,000. And then just for completeness, we'll see year five is 35,000 for the cash inflow, and our total cumulative net cash inflow is going to be 150,000. So that's 330,000 cash inflows minus the 180,000 cash outflow. So we see that the payback period is going to be somewhere between year three, the end of year three and the end of year four. So in order to get a precise number for how many years does it take to pay back the 180,000 we had as a cash outflow, we are going to divide that 10,000 we still had to make up after year three by the total amount of cash inflow we had in the 4th year. So we had 125,000 spread across the 4th year, and we needed 10,000, the first 10,000 to get to that payback. So we take 10,000 divided by 125,000 to get 0.08. So after 3 years, we had 10,000 as a net cumulative cash outflow, and then another 0.08 years to get the remaining 10,000. So our payback period would be 3.08 years. So exercise 24-2, we're going to use the same fact pattern, same cash flow for the outflow in year 0 and inflows in years 1 through 5. Here we're going to look at net present value. And what that's going to be is those dollars in years 1 through 5 are not worth the same as the dollars in year 0. You'd rather have a dollar today than a dollar tomorrow. And the reason why is because of either inflation, or we can earn a return on it, or there's interest that's just going to be taken over that period of time. So we have a required return that we need to make on our investment. Here for this company, we're going to set it at 10% is what we need to return. So we want to know, is this going to be a net present positive value or a net present negative value, and whether we should accept the investment or not. And then we also want to quantify what that amount is. So we're going to start out the same way with years 1 through 5 on the left, the cash inflows on the next column. And then we are going to use a table from the textbook in order to do this calculation. We'll take a look at every panel of that table. But it'll have on the table that you could also do this computationally as well. For this exercise, we're going to use the table though. So we're going to do present value calculation because we're discounting those year 1 through 5 cash flows back. And because they're not the same, we have some at 60,000, some at 40,000, it is not going to be an annuity. So we'll use the present value of $1. Had every year 1 through 5 been an even amount, such as 60,000 in every year, then we could have used that annuity. But here with different cash flows in every year, or at least not the same cash flow in every year, the present value of $1 is what we're going to want to use. So we're also going to want to know the number, the year of the cash flow, as well as the interest rate, so that's the amount we're discounting it back. So we'll take a little segment of the table. We'll show you the whole table shortly, but this is just the segment that's going to be relevant for this exercise. We're looking at periods 1 through 10. We only really need periods 1 through 5, and 10% for the return that's required. So if we look at period 1, 10%, we'd have 0.909. So we're going to multiply that times our 60,000. So 60,000 a year from now to us is worth 54,546 today. So if we only had that 1 year cash flow, we would be willing to pay 54,546 for a cash outflow just for that year 1. If it cost 54,547, that would be $1 too much, and we would not be interested in doing the asset purchase. But we have more than 1 year of cash flows here, so we're going to do each one in turn. We can notice on the right-hand table section, we have period 2, 0.8264, so we're going to multiply that times our 40,000. Year 3 is 0.7513. We're going to multiply that times the 70,000. Year 4 is 0.6830 times the 125,000. And then year 5 is 0.6209 times the 35,000. And then we're going to want to add every one of those present value in years 1 through 5 up to get what the get what the total present value is. And then we're going to want to subtract the 180,000 to get the net present value. So we have 247,300 is the present value of cash inflows. 180,000 is going to be the present value of cash outflows. Again, we don't have to discount that back because it's already in year 0. So our net present value is going to be 67,300. Because that's a positive number, we would want to accept this purchase, provided that we're not comparing them or contrasting them with other opportunities that we're going to want to pick the best one. If we're just looking at this as 180,000 sitting in cash or 180,000 invested in this project would be a net present value positive purchase, so we would want to do the purchase, and we'd expect the value for the company to increase by 67,300 as a result of that purchase. So looking at those panels, so this is the panel for the table that we just used. Looking at the third column from the right and the first 10 rows there is what we were looking at for the section. But you can see that we have multiple periods that we can use, and we also have multiple interest rates here. This is used for discounting future cash flows back to the present present date. We also have the future value of $1. So this is going to be, if we wanted to take our 180,000 cash outflow, and see what that would be worth based on a certain rate for a future. So example, if we wanted to take 5 periods out at our 10%, we would expect 1.6105 for the multiplier. So we'd multiply that times the 180,000 to see what that 180,000 at a 10% rate should be worth in 5 years. And that would be a cumulative 61% increase. And you'll note that 1 period, the 10%, would just be 1.1 or a 10% increase. And that year 2, 1.21 or 21% increase, and the fact that it's not additive is because of compounding. So we're multiplying the 1.1 times 1.1 to get 1.21. You can note that the formula is on the top of these panels as well. So going back to table B1, that is the formula that we used to get that table result from the section. So that would just be 1 plus the interest rate, that 1.1 times the number of periods, and then you want to take the reciprocal of it to discount it back. So on the other side, we've got the annuity panels, and this is going to be if those cash flows are even, and we only do one calculation instead of 5 separate ones. And we'd have in table B3, present value, so again, discounting it back, and then future value of annuity, or else the advancing that forward based on that rate. And again, annuities being even cash flow, and then the present value or future value of $1 can be used whether it's an uneven amount of cash flows or whether it's an even amount of cash flows, but you're discounting each of those years back individually or else advancing them forward.